Hello guys. So we have a very hard Leetcode problem. Remove invalid parentheses. Question recently asked by Google and Facebook. Okay, so given a string S that contains parentheses and letters, remove the minimum number of invalid parentheses to make the input string valid. Return a list of unique strings that are valid with the minimum number of removals. So you may return the answer in any order. Okay, so we know what a valid parenthesis is supposed to be, right? It's supposed to be a parentheses with the correct number of what both opening and closing braces, right? So for each opening brace, there should be a closing brace. For each opening brace, there should be a closing brace. And the closing braces, right, they don't occur without there being a preceding opening brace. And the opening brace doesn't occur at the tail end where there's no what later occurring closing brace. So what we want to do in this problem is first find the number of imbalances, right? And you can see from this string, for example, you can see this open parentheses, close parentheses, open parentheses, close parentheses, and then have another close parentheses, right? So I would see this as an imbalance, right? Open, close. So we would have with the number of parentheses I'd have to remove, I'll be looking at removing this one. For here also, pretty much you have open, close, and another close, right? And then have open and close again. So this closed, I see it as an imbalance because it has to know what corresponding opening parentheses. So if I wanted to remove anything, this is the one I want to remove. Really simple. And here, right, we have a close with no opening with no close, right? So the permutation for here, we can only have an empty string to release. So basically what I want to do is to find the number of imbalances, right? And then I'll use DFS to generate the correct permutation of strings, basically. And then we return that. So the DFS is kind of like a backtracking. And I once you get into the code, I hope you guys can see exactly what I'm talking about. So let's have a set of string, right? Of string. And then, in fact, let's go first and find the imbalances, right? Slash the number of removals. So we have int left, int right. Where left is what the number of opening parentheses that we want removed, and right is what the number of closed parentheses we want to remove. So to count the imbalances, right, we have to loop. So for car C in S.2 car array, right? If C is equal to what an opening brace, then I'm going to increase my left, knowing that if I meet closing parentheses, then I can decrement my left, basically, right? So the only left that's left, or the only left that is the only left that remains at the end of the decrements, right? It will be one where the left parenthesis has no what corresponding closing brace, basically. So else if C is equal to a closing brace, right? Then if our left is greater than 0, then we want to decrement our left, basically. Else we increment our right, right? So this helps us get the imbalances, right? And I have an int I call n for the number of opening braces, right, that we want in our new string with no imbalances. So that will be n is equal to the length of the string, right, minus right minus left divided by 2, right? So whatever length we get, say 6, we divide by 2 for the number of opening braces, and then for the number of closing braces, essentially it will be the same n, right? And then I want to do a DFS, and actually I want to do it on S.2 car array. So I to car array. I need my left, right? I need my right also. I need my n. I need a number of opening parentheses, closing parentheses, and I want the set. So the set is what I'll add my generated strings to. There might be duplicates. That's why it'll come in handy to have set, and we can easily convert a set into what an array list by doing this. So in the end, we can return an array list. I think the only thing we are missing now is another 0 here, where this 0 should be our starting index, right? The index at which we are looking through the string. So let's do our DFS. It's called I left R, it's left, it's right, it's n, start, open, close, and hash set, basically. So to avoid having to generate strings, right? Where we generate strings and then we have to check if our strings are valid parentheses, right? Then we have to make sure that the strings we are generating, they have to follow the configurations for what valid parentheses would be. So that means also, and let me have it, it has to be that we have our open should be less than what our n right here, where n is the number of possible once we could have. And if our open is less than our end, then what we can add the opening parentheses. And if our close is what less than an opening, our open, right? Then we have what we have space again for the close parentheses, so we can add it basically. That's one way I'll be going about doing that. So the focus of this DFS is to simulate both adding and not adding. So essentially, if you don't add something, it's essentially like removing it. So let's say I went through and I said, okay, I'm adding this to our string, and I think I didn't name that as a variable here, so I have to do that. But let's say we're adding that to our string, right? Now, when we choose not to add it, essentially we are removing it from our string, right? So basically, that's what we're going to simulate. We're going to simulate adding and not adding, or essentially adding and what removing. So I think we need here. Let me put it in appropriate place. So a new string builder. I want to use a string builder because that might be faster. The new string builder. So I have it after. So don't call it the current. Okay. Builder current. Let's break it. Okay, cool. So we need our base case, right? And our base case here, we should be handling errors. So if our left or right, we will be decreasing our left or right, or is the number of open and close parentheses respectively that we want to deleted. So if in the case where I'm simulating not adding, or I'm not adding them essentially, right, I'm going to decrement both the left and the right depending on the case, or depending on the kind of parentheses that we are not adding, right? And I want to check if our left is less than 0 or our right is less than 0. But if so, then definitely there's an issue, so we want to return. And also if our start is greater than the length of our entire array, right? Then we've gone through the entire array. So again, we should return. And the base case for adding to the set is to say that number one, our start should be at the end of the array. And we also want both our left, right, that's the number of imbalances, and our right to be equal to 0. And if so, then we say set of add current to string, right? And then we return. Else we return basically. Yeah. Okay. Sounds good. So I would say if our start is less than AR, just length, then I want to do DFS essentially, right? So if let's call the current character C. So that's AR start. And in fact, to allow for our backtracking, we want to set the length. Right? So length is equal to the current length, right? So backtracking, basically, we make certain decisions, right? And we can always revert essentially. So if we made certain additions to the current, right, and we didn't like that in our decision tree, we can always go back and reset our length. So that's what using a string builder and backtracking allows us to do. So if our C is equal to the opening brace, right, then what we want to do is what we want to simulate adding or removing essentially, which we already discussed. So if our open is less than n, then if our open is less than n, then wherever we allow to what add essentially, or we can also do nothing, right? So if we add, we'll see our DFS, our left stays the same, our right stays the same. Why? Because we are not simulating removing any of them. And then the current dot append, and we are going to append what's this opening brace, which is C. And then n stays the same, start increases by 1, so we go to the next one. And then our open increases by 1, and our close stays the same essentially. And then we add the set also. And here we are simulating adding opening brace essentially. Right? So if we are adding, then we want to allow ourselves to backtrack. So we'll say character.set length, right, to the original. In case this decision tree doesn't yield what we want, right, we can backtrack, right? Or we can also simulate not adding essentially. Now, simulating not adding this open parenthesis means we are removing essentially an open parenthesis. So what we want to do is to decrease what's left by 1. And then we have the right, we have current dots. Now we are doing nothing, right? So the current, we don't append, and we have n, and then we increase our start by 1. Open stays the same because we're not adding, right? Close stays the same, and then we have our set. Okay, sounds good. Else means we have reached the point where what our open is at least equal to n, or is even greater. In this case, we shouldn't add any parentheses, but if we do that, then we are making sure that our parentheses, right, or the permutation of which you have doesn't have it balanced. So what we'll be doing is that we are getting an invalid one, and that's not what we want. So we want to essentially do the same thing that we do here, where we simulate what's not adding, essentially, right? Because that's the only thing that we can only not add in this case. Copy and paste and say add-on, right? So else if C is what the closing brace, right? Then we want to say that we can only add if what our close is less than open, right? So every close which will be added based on this is doing so because we have a corresponding opening brace essentially. So yeah, so then we can simulate what's adding again, left, right, and here we have a current dot append where we are adding C, and then we have our end, increase the start by 1, open stays the same, but because you're adding a close parenthesis, we increase close by 1, and then let's stay the same. So here we are adding what's the close parenthesis essentially. And then again, we want to allow for backtracking, and we also want to simulate for what's not adding essentially. So our left stays the same, but our right, because we are essentially not adding and essentially removing a close parenthesis, right? I reduce our right by 1, and then we say current stays the same. We have n, and then we increase the start by 1, and then open, and the close stays the same. Set also stays the same. We are not adding. And again, like in the first one, right, we implement the same logic where we also what, if this case is not being met, right, then the only thing we can do is what, simulate not adding. But I don't add to a messy situation essentially. So here, simulate not adding to our left, and again our right decrements by 1, right, because we are not adding that closing brace, and n starts plus 1. Our opening brace stay the same, close brace stay the same number, and that is it. And now the question also says that we could have what letters, right? You can see an A here, so that is the else case, right? And the else case, the only thing we can do in that scenario is what, to add the character we have. So we have a DFS, right? R left, right stays the same, but I'm not dealing in parentheses, and then current will append C. N stays the same, and start plus 1, open, close, and then set. So we are adding the character. So adding letter, basically. So that should be it. Let's run the code and see. Gets accepted for all of them. Let's see. Right. So guys, this is the an efficiency solution, right? Beating 86%, almost 90% of other users. I combine the logic from using generate parentheses, right, which is a different Leetcode problem, and I will be. You can check our video on that. So we combine that to make sure that we're generating the right parentheses. And so I'll say maybe the only thing that you need to know outside that is what to find the number of imbalances. And this, I hope this is a very helpful video in the end. And if you like it, please like and subscribe. Thank you for more.